Okay, hello everyone. We are going to talk about how verifiable machine learning will save the future of ML. And this is not to focus on CK, but verifiability as a feature. AI is a hot topic right now. As you all probably know, it's growing very fast. Adoption is occurring in almost every company and for all consumers, basically. We have exponential growth over the next 10 years for AI, so this doesn't come without problems or complexities. So, for example, here you can see what are the biggest complexities when you're trying to build AI and machine learning, what kind of problems these companies face. So mostly it's related to curating data, training, but also one of the biggest problems is how do you actually deploy the models, how do you perform the monitoring for these models, and it's not an easy task. And this is because most of the AI stack is very complex. There is a lot of technical debt, it's not unified. There are like many different things that you need to manage, from data collection, verification, deployment, training. You need to figure out how the monitoring works. So it's a lot of things that you need to put together in order to have these production-ready systems for machine learning. So also comes with a cost for verifiability in the inferences. As we progress with adoption, and in the AI space, for example, here is a short blurb from the EU policymakers, where they are discussing how verifiability for AI is like critical for them. Like, if we are like making high-risk decisions in companies, we need to have a way to verify that what we are providing to the customers is traceable and transparent in a way. And this is a not solved problem for now. So the best thing that we can do for now is just provide good monitoring, but not full traceability. There's like some tries of having traceability and provenance for model inferencing, but it's like more based on the application layer, where you add like labels to the images that you generate, for example, in Photoshop, for example, but doesn't come down to the model level. So what we are trying to do is, what if we can have full provenance of the model directly in the model layer without depending on the application that we are using? Now we are going to focus more in how these AI solutions are being used. And in this specific case, we are going to look into the banking ecosystem. In banking, it's very common to use ML for a wide variety of tasks, like from credit risk scoring, from risk modeling, portfolio management, risk factors in different market environments. But the thing is that even though it's like very widely used, there are like still restrictions and complexities because all these problems that I mentioned earlier. Like, how do you manage this technical debt in highly complex environments from the whole end-to-end pipeline for AI? But now, for example, in DeFi, we're facing like very similar problems in terms of how do you manage risk. For example, there is this very well-known case of Curve, but also all these hacks that are happening in DeFi. And the thing is that we need an easy way to have provenance in AI. Till now, there is no easy way to do that without creating a huge overhead of complexity in these architectures, or just like having full trust on what you are building, like trust me, bro, of what my solution is good. But the thing is that as the market is evolving, regulatory policy making is also evolving, and there is going to be regulations that need to happen also in AI. But for the blockchain also means new possibilities. With the technology that we are building, now we can have all these ML functionalities that are being used in banking, fintech companies, for risk score modeling, portfolio management. All of that, we can have it now also in DeFi without any kind of trust assumptions, thanks to the usage of zero knowledge proofs. So now we can have all these models doing risk modeling, being executed off-chain, verifying these computations on Ethereum, and be leveraged by any kind of DeFi protocol. So it's like a new way for DeFi applications to broaden the scope of the capabilities they offer. Also, is improved risk management. We see all these problems that are like with liquidations, how much collateralization there are in these protocols. And now all of that can be also be improved by the use of this technology. And we are like seeing different protocols be interested in this technology to improve these pipelines. Sorry. But this is not just about blockchain, because it's about the whole AI space. And for the whole AI space, there is also a lot of improvements in terms of what we can provide using verifiable machine learning to these architectures that companies are using. Like, for example, simplifying auditing processes. One of the biggest restrictions of why, for example, banking or highly regulated companies are not using AI at the moment is because they don't have a clear way and cheap way to actually have this provenance for the whole pipeline. So it's very beneficial for healthcare companies, banking, fintech, to have a very clear way to have the provenance of the inferences. And the last one is more technical, and it's about the infrastructure stack and how they manage technical debt. For now, to have this verifiability in some way, they need to build a complete overhead of architecture to monitor how models are being used in production, how they are generating the inferences, where these inferences are coming from, which model is it, and basically everything. But now you can just remove all of that and execute your model, have the associated sticky proof for that inference, and that's it. You have the provenance of which model is being used and what inference is being generated. At Giza, we are like simplifying all of that. We don't care about the technology. We want to solve problems. We want to provide good value with a real product that companies want to use. And that's the reason we are building a complete end-to-end machine learning solution for verifiable machine learning. We cover the whole pipeline to simplify all this technical debt that now companies have, from data acquisition, training, but our focus is on the inference side, where we can have this full traceability at a low cost. CK is the core of our technology and what we are building for doing inferencing. But we don't want users to know about what is CK, how to program using CK frameworks, or how to use Cairo. We don't care about that. We just want the user to have an easy development where they do the training as they want, they use the data that they want, build the model, they give us the model, and we just handle everything for them. From the deployment, scalability, verifiability of the inferences, the proving, basically everything that these companies need, we handle for them. And for this, we are building Orion, that is our framework for doing verifiable machine learning. It's completely open source. It's built on Cairo 1. And with these foundations, you can basically build anything that is right now possible in the AI space. The API is very standard to machine learning people, which means that you will have a one-to-one representation of the same API that you can have, for example, in frameworks like PyTorch. And this is like very convenient for people building ML because it's like something that they know how to use and how to build on top of that. Also, it's multi-backend, which means we can easily support new frameworks that are coming in, not only on the ML side, but also in the CK side. is there is some new innovation that is like a complete breakthrough into the ecosystem to have cheap proving or inferences. We can easily integrate it in a very easy way with maintaining the same API. So for the users, there is no change. They will continue to use their same functionalities, the same way they are doing it, but in the backend, maybe something different. But they don't know. And one of the things that we want is to have all the support as possible for ML frameworks, so people can build the model they want with the framework they want. Doesn't matter if it's PyTorch, if it's TensorFlow, if it's scikit-learn, whatever it is supported, and everything is bundled into a single standard API that they can use very easily. So that's it. Thank you very much. If you're interested in building verifiable machine learning models in your company or your protocol, just reach me out. Thank you. Question?
How would you compare what Giza is building in terms of really interactive and intuitive dev tooling with something like what Modulus Labs is building that's high caliber ML engines or like ML specific proving schemes? So what's the difference in the business model or what you're trying to do with how you fit into the Starknet ecosystem?
Yeah, very good question. We want to be the platform that is user-facing, so it's like the entry point for people to come and do verifiable machine learning. Under our platform, there can be a different kind of frameworks or proving systems that are supported. So our idea with Modulus is they are building a very good prover, and the idea is to integrate it down the line, as we can integrate also Stone prover from Starware or Lambda class prover, so we can support other kind of proving systems to be integrated into our general purpose machine learning platform. And the idea is that the user doesn't care about what is happening underneath. Basically, we will use the best technology that is available to provide verifiability to machine learning models. Okay. Thank you very much.